Okay guys, so today we're going to look at the derivative at a point, or the slope at a point. So we're going to start by looking at 0, 0. And we're going to look at what happens when we try to calculate the slope at 0, 0 by using points closer and closer on the left. So we might take a point like negative 0.1, negative 0.001, negative 0.0001. We're trying to get an idea for the pattern as we use x's that are closer and closer to x equals 0. So I'm going to use the point 0, 0 and the point negative 0.001. And then the y value that goes with it, which I'd get by squaring it. Okay, so now to calculate the slope, as always, we do the change in y. So it's like the negative 0.001 squared minus, so the changes in y, divided by the changes in x. And when we simplify this, we end up with negative 0.001, which obviously is very close to 0. And you could try this yourself and plug in a couple x values closer to 0, and you'll see that as x gets closer to 0 from the left, the slopes that we calculate are going to get closer and closer to 0. So we'd say that the left-hand slope is 0. Now let's do the same thing on the right. So we have our point 0, 0, and then we could pick a value again that's very close to 0, like x is 0.001, and then the y that goes with it would be 0.002. The way I'm getting that is I'm looking up here and it says that if x is bigger than 0, plug into y equals 2 times x. Okay, so now again we'll do change in the y's over the changes in the x, and that gives us 2. So on the left-hand side, as we come in, the slope approaches 0. On the right-hand side, the slope, we can see if we look closely, will always be 2 because the equation for the right-hand side is y equals 2x. So that will obviously always have a slope of 2. So we'd say, in general, the two-sided derivative does not exist. The left-hand derivative and the right-hand derivative are not equal. So the left-hand derivative and right-hand derivative aren't equal. So the general derivative doesn't exist. So and what we would just call the derivative. So the derivative at x equals 0 does not exist. So doesn't exist, or DNE. And another way of saying that would be to say that we're not differentiable. Okay, so now let's look at the next page and look at some other examples. So we're interested in the derivative, or the slope, at x equals negative 3. Well, we can see that we have a line here, and the slope along a line is always the same. So you can see here just by counting, we count over 3, down 3. So slope is just change in y over change in x, which you can see here is negative 1. Okay, now we can see that we have another little line segment on the other side, and we're interested in the slope at 1. So to get the slope at 1, we just notice, okay, this is a standard line. We can get the slope by counting up and over. So you can see that the slope here would be 1. All right, in 4, we're interested in the slope at 0. We can see that the pattern as we come in on the left is that the slope is negative, and on the right, the slope is positive. It looks like maybe, it's negative 1 here and positive 1 here. So the slope right at 0 is undefined. Okay, let's look down at 5. So for 5, they're telling us that the position of an object is given by f of t. And they're asking us what f prime of 5 means. Remember, the derivative is always change in y over change in x. You just have to fill in the real world information they're giving you. So they're telling you that y is the position and x is the time, or t is the time. So it's change in position compared to change in time at time 5. Okay, guys, now let's look at 6 together. So for 6, we're trying to draw a graph that has the function slopes as its y values. So we can see that we have 4 little line segments. And so the y on our derivative graph should represent the slope at each point. So if we first look from -4 to 0, we can see that the slope is up 2 over 4. The slope is a half. So on our slope or derivative graph, we're going to draw a line straight across at 1/2. Now I have an open circle at 0 because the slope right at 0 is undefined. The slopes on the two sides are different. We do the same thing for the next part. We can see that the slope is -4 when x is a number between 0 and 1. So we draw a straight line across at -4. Then we move on to the next part. We can see when x is a number between 1 and 4, the slope is 0. So we draw a line straight across at 0. Then at the end, we can see that we count up 4 in the y's and over 2 in the x's. Our slope is 2. So we draw a line straight across at 2. Okay, now they ask us in the next part, where is the function not differentiable? That means where can we not take the derivative? And that's anywhere where the slopes on the two sides don't match. So you can see that at 0, the slopes don't match on both sides. Also at 1, 4, and that's it. Because at 6, there is no pattern on the other side. So you're okay there for the derivative.